We're going to, still in Unit 7, we're doing proportions and similarity, this whole unit, this whole unit. And right now we're doing the second section of the unit, and it's properties of similarity. Okay? All right, so this was review from just a couple moments ago. Could be days if you're watching this later, but it's right now, just a couple moments ago. We had a proportion. A proportion was two fractions that were equal. We said that the extremes were the diagonal from left to right, and the means were the diagonals from right to left. The cross product, we just took those means and extremes, multiplied them, and put them on opposite sides. There's going to be one more. There's two more. There are some other properties. We can move some numbers around and keep this ratio equal. It's really some cool things to help, and if you learn how to use them effectively, it can help you solve equations faster. Okay? I want you to notice something. I want you to notice, I've got the same thing on there as I had before. You guys have learned that if I take 5 times 4, that's the same as 4 times 5, correct? Yes. So I could take that A and that D, and I could turn it around, right? Mm-hmm. If I took the A and the D, and I put D before A, that would still make the equation okay, correct? Yes. What's that like over here on the fraction?
You're going to take the C and the D and you're going to flip it and move it on the other side.
I'm going to actually, instead of the C and the D, I'm going to flip the A and the D around.
Yes.
And that would be legit in the sense that the cross product would be the same. So, here we go, let's try that. So I could switch, would it still work for the extremes too? Could I flip?
Yeah.
I could flip the B and the C, correct? And that would be legit also. So,
this is addition property?
this is that one's called the means property and one's called the extremes property. Okay, so let's look over here on your Formula Madness. Over there, when it has the means property, if I flipped around the means, which are these two.
So it would be AD equals DA?
Oops.
Is that what that would be?
A second. Let's go back a little bit. I'm going to get back in here. So if I flipped the A and the D and left the C and the B there, I would have D over B equals C over A.
That's what you want me to
That's
write.
what you're going to write in that box for your Formula Madness. Okay? I'm flipping. Is that one for the extremes or the means, by the way?
Means.
Oh, wait.
Wait.
Wait, what?
Means.
You're not talking about I write it anywhere, right?
I think it's extremes. A and B is extremes, isn't it?
What?
A and D is extremes. That's what you wrote.
Oh.
A and D is extremes and...
We put on our
Yeah,
Formula
okay.
Madness, we put it backwards, Amy.
Okay. That
Alright.
makes sense.
So you guys understand what you're supposed to write there, correct?
Right, it is for the extremes, right?
That was for the extremes, so
yeah.
you're right.
So
Yes.
what's
Okay,
the
got it.
point of flipping them like that?
Oh, a good question. We'll do that in a little bit. There's tons of things you can do with it.
To make math confusing.
No, it's actually not to make it. It's actually going to. There are times when the variable is on the bottom, and it's easier if you could make it be on the top and solve your equation easier. And if you can just flip that around fast, it's better. All right. So what then? Oh, I shouldn't have.
Just really quick variation.
What if I want the extremes one then? We just did the extreme one, right?
You just flip the C and the...
Yeah, so I'm this time going to do the means, and I'm going to flip that. So my A and my D will stay the
Do we
same.
need to write that in the same box too?
No, the other box. The means property now.
What?
We're doing the extremes property now.
But we're doing the reciprocal property.
No, not yet. Not yet. We're doing the means and extremes property. Okay? I'm going to put a C down here and a B down there. Okay? Nobody made this up. They didn't sit in some warehouse or some strange little library in the basement and say, you know what? Let's see if we can make math really hard. Let's make the extremes or means property. No, math just works this way.
So that's called the mean.
It's because it's really mean.
That's why it's called that.
So no little mathematician sat down in the bottom of the science and math department at some college and said,
Make
let's
it
make up
hard
a
on 'em, make 'em
really
hurt.
mean property.
That's exactly.
It's just the way math works. If you switch those around, it stays legit. Okay? Questions?
You're not going to make us do these in proofs, are you?
No, don't stress. All right. Now we're going to talk about the proportion reciprocal property, or in yours case, it says on yours, the reciprocal property. If I flipped, and I did the reciprocal of the left side, so I said B over A, it will equal the reciprocal of the other side. So then I flip this one and do the reciprocal of that side, put the C and D. I want you to look and see if the cross product will be the same. The cross product will be the same. B and C
So does that go
is
in the
here.
reciprocal property?
That goes in the place of a reciprocal property. And A and D are still going to go together, so it's still going to work out. It's still going to work. You can take the reciprocal of one and will equal the reciprocal of the other.
I don't know why it doesn't make sense to me, but what is even the point of flipping it if they're going to give you the same answer?
When we do some,
If
when you
have
solve
the
equations,
equation,
if you solve some equations, and it's going to be easier to solve if I flip it once instead of having to do a bunch of steps.
Okay.
You can use it. Okay? All right. Let's do the last property, and it's called the addition. I have proportion addition property. On your paper, you have it as the addition property. Okay? This one's going to be different than all the rest. If I took, I'm going to just bring it on out here. You have the first one.
Ugh.
This is what you're going to write in on your Formula Madness page. It's also,
Where?
I'm going to let you just write it down, then we're going to talk
Where
about it.
at?
On addition property.
Oh.
Okay. You can also put this on your notes pages. I'm going to talk about it after you write it, so I'm going to give you some time. Oh, by the way, wait, guys, I'm sorry. You do not have to, this is the part you need to write in your Formula Madness box. This. Only that part. This part's given to you. This part I gave to you at the top in my writing. You only have to write that part. I was like, why is it taking so
Just a
long?
wee bit too late now.
You can, good job. Because you're very, what's the word I want to use? Efficient, Heidi. Efficient. All right, you don't have to write this down if you don't want. This won't go in your formula box. If you would like to put it on your paper over here, I've given you a place on your notes for all of those properties. I'm going to give you one with numbers, okay? So if I have 3 over 4, that equals, if I multiply by 2, I'll get 6, and I multiply by 2, I get 8. Okay, that is a proportion, and it's true. The addition property says A plus B, that's the numerator plus the denominator, divided by the denominator, okay? So that's 3 plus 4 over 4. I'm going to write it over here. I might do something a little different. Let's do this. I'm going to move it up. That's 3 plus 4 over 4. It should be true. This says that I could do the same thing over here. I take the numerator plus the denominator over the denominator. What does that make for this? You can write it here.
6 plus 8 over 8.
6 plus 8 over 8. Let's try it. 6 plus 8 over 8. Is this a true statement? Does this actually reduce to the right thing? What is 8? Excuse me. 3 plus 4. 7. Let's reduce it and see. 7 over 4. What is 6 plus 8? 14 over 8. Is this a true statement that I just wrote?
Yeah.
Because this reduces. 14 over 8 does reduce to 7 over 4. Okay. So if I took numerator plus denominator over denominator of 1, I can do the same thing on the other. Okay. That's the addition property. It's the what property?
Addition property.
The addition property. Amy, you have a question? You gave me some growls that gave me indication that you might need have a question. No? Okay. All right, let's do some like you'll have on your homework.
Are these the ones we will have on our homework?
Yes. Number 7 and 9. 7.2, 7 and 9.
What is this?
We're going to do that in a minute. Don't stress. Don't stress. Let's jump over there, okay? Number 7. You're going to fill in the blank. I have A over B equals C over D. I am now going to, if this could be the means property, it could be the extremes property, it could be the addition property. If I have B over A,
C over D.
how did you get that? Not C over, what did you say?
D over C.
D over C. Which property did you use?
I just put like
The reciprocal.
That's correct. Notice that A over B got flipped to become B over A. And now you have to flip the second one. So it is D D over C. This is what you're going to have to do. You're going to have to figure out how did it become B over A? Then you'll have to do the same thing on it. Let's go to is there any questions on number 7? Let's go to number 9. Skip 8. As much as temptation as it is. A over B equals C over D. How did I get A over C? What was done to this to get A over C?
You did the means reciprocal.
So this C came down here, correct?
Yeah.
So what has to be up here then?
B.
B. So these got flipped. So what's going to be written over here?
B over D.
B over
D.
B over D?
B over D.
Yes, B over D. My bad.
Wait, what property is it?
And you don't have to list a property, but you could. They was that means or extremes? Means.
Extremes is
This is what I'm gonna have to do to remember, because this direction, I'm gonna put an E up there, and this one has an M, and they go in alphabetical order. E comes before M in the alphabet.
I was just thinking that the first thing, if you're going
So
left
it was
from
means.
It was the means.
I was thinking from left to right. B is a consonant, and so is M. E is a vowel, and so is A.
Ah,
That's what I'm thinking.
I see. Okay, that works too. Okay. I do alphabetical order a lot. All right, questions. All right.
What happened to number 10?
What happened to number 11?
Oh gosh. I'm trying
Dot's supposed to be
All
there?
right, let's do number 5 really quick. Let's do number 5. We're going to go back a little bit to number 5. I am giving you a ratio, or two ratios, a proportion. We're going to substitute in and find B, D. So if I here, for this here, the top one,
So do we
Is-
put X for BD then?
yes. AB equals how much?
20.
So I'm going to put a 20 in the place of the AB. That's at the top left. What about BD? That's X.
Equals 16 over 9.
16 over 9, I heard. Okay. You can cross multiply. $16x. And 20 times 9 is
180.
180. Good job. Divided by 16. I think it goes in evenly.
It does not.
It does not. It doesn't?
No.
Fraction or decimal as an answer?
Fraction.
How much?
Fraction.
What'd you guys get?
45 order over 4.
45 over 4. Is that what you got?
I'll put it in a fraction.
Yes.
What'd you get for your decimal?
11.25.
I want to see if your calculator might even convert it. You got 45 over 4. Is that correct?
Yes.
Ooh, that 5's terrible. There.
It's all right.
No fraction in the original. Excuse me, no decimals in the original, so no decimals in the answer. All right, that's how you'll do, very similar to number 6. We're going to go back and review and go a little bit more in depth into some square roots. We're going to be using square roots this unit and next, okay? This, number 9, says 2 square root 5 times negative square root 2. I personally, when I have a multiplied by a negative, I like to put it in parentheses so that...
Where is this at?
This is number 9.
On what?
7.2.
7.2.
Oh, that's not true. This is number 11. Number 11.
That's the number 11.
Number 11.
Yeah, 11, 13,
11,
and
13. 11, 13, and 15.
and 15.
Okay, 11, 13, and 15. Let's go back. So, the way we multiply when we have square roots is we multiply the numbers on the outside, and then we multiply the numbers on the inside. So this is a negative 1 right there. What is 2 times negative 1? Negative 2.
Negative 2 square root 10 is what I got.
And square root 5 times square root 2 is square root 10. Before we stop, though, you need to check. Is there any perfect square roots in there? Let's go over that really quick.
There's not a perfect... Oh, wait, part.
We haven't gone in depth in this, but some of you asked me and I sent notes on it at home. And so 10, what multiplies to be 10?
5 and 2.
5 and 2. Are any of those perfect square roots?
2 is...
2 is not a perfect square root.
No, it's not. No.
Okay, so if there's no perfect square roots in there, or there's no doubles, there's not a thing listed twice, you are finished. You do not need to do anything more. We're going to do one in a minute where we will, okay?
Wait, I forgot. Is a perfect square root to where it's like 2 times 2 equals...
Yeah, like 4 is a perfect square,
Okay.
9 is a perfect square because it's 3 times 3, 16 is this perfect square because it's 4 times 4,
I have a feeling there's just one.
okay? Let's do you said this wasn't 9 up there, that was actually 11. Is this one, is this 13?
13.
Okay. Number 13. Square root 15 times square root 20. Since there's nothing on the outside, we're just going to leave just 1 out there, so it's 1 times 1. What is 15 times 20?
300.
How much?
300.
300 even. Okay, so there are some perfect square roots in there, so this is what we do. We come over to the side, and we write 300.
3 square root 100.
3 square root 100.
But then
Are any of those perfect squares?
100 is...
100 is, you could stop if you wanted to, or we know that that's 10 times 10.
10, 3. 10 square root 3.
Yes, so it's 10 square root 3. Yes.
Yay.
That makes me feel good that you guys are on the ball with that. Yes. Because the 10 is doubled there, and it can come out as a single. Have we done that before in this? I know that some of you have, because I showed you individually, but I don't remember if we did it in class together.
Holy.
10 square root 3. My bad, not
Yeah,
5.
I was gonna say that.
I saw somebody in the room looking at it kind of suspicious.
I just always forget that.
All right. Next one, number 15, not 13, but 15. What is 10 times 15?
150.
150. If I come over here and did 150, that's going to be 10 times 15, by the way. We just did it. Which this is going to be 2 times 5. And this is 3 times 5. Are there any doubles in all these that I wrote here?
No.
5 is a double.
5.
That's right. The 5 can come out of the 150. But what would be left on the inside?
30.
No.
No, wait.
Wait, what?
Okay, we took out...
The 2 and the 3.
Yeah, because this is going to be really...
6.
I'm going to write
I
it.
got
2 times...
5 square root 6.
That's exactly what you're supposed to get. How'd you get that, Brett?
My calculator.
Does it really do that for you?
Yeah.
Naughty. Let me tell you how it's supposed to work so that you... Because the letter... You might be doing...
You put those down and then you add them all together.
Yes. So we took the 5 out, right? And it became the 5 on the outside.
It's just easier.
And we did the... And instead of adding, though, we're actually going to multiply the 2 and the 3 makes 6.
Yeah.
Okay.
Mine kind of has a thing where it doesn't. I just type that in and it kind of gives it.
It gives you at least the 5 on the out, the 5 point something, but it won't give
Yeah,
you...
I
It
just
won't
kinda-
do what his does. I know for sure your 2 don't.
They don't? Oh,
They don't.
Alright.
Because these 2 calculators can be used on standardized tests, and they want you to be able. They don't want you to know how to do that, so they've kept them
Oh, yeah.
scaled down a little.
I kept them dumb.
All right, I didn't say dumb. All right, we're gonna do something called the geometric mean. A couple of you were saying, "What's geometric mean?" I told you in a minute. We'll get to it. So you'll need this for your notes and your formula madness. Okay, so both of them. So go ahead and get back to your notes.
Wait, is that what the geometric mean of Z and Y?
Yes, we're going to do that in a minute. So geometric mean on your note sheet. Do you have this written on your note sheet?
No.
No.
Okay, so go ahead and write A over X equals X over B.
Where?
Underneath
Under
geometry.
the word geometric mean on the, I'll show you. Right? Oh, so right, no, not right. Ah, there. Okay, all right.
Did we do these two?
Yeah, but you wrote those on your Formula Madness, okay? All right, everybody knows where you see where we are, right? You can do it there, but we're also on, because we're going to solve some stuff. So go down to the bottom of the page right there first, okay? All right. Geometric mean will always have two X values. And they will always be either on the extreme or on the mean. They will always be diagonal from each other. Okay? We're gonna do the algebra part first, and then later, in a couple more units, we will use this to find links of parts of triangles. But right now, you're just going to be concentrating on the algebra of it, not the why it is set up like this. Okay? All you need to know right now is that geometric mean has X values on a diagonal always, and two numbers that are on diagonals also. Okay? If I was to cross multiply for this, or solve for X, I would do it like this. We're going to cross multiply. What is X times X?
2x.
Nope. Careful. X squared.
It's plus x.
And A times B is just B. You with me so far?
Yes.
Okay.
And then I would
How
just
do I
square root of
get,
both
then
sides.
to get the square off, I take the square root of both sides. So X will equal the square root of A times B.
Can't you just write AB?
You can just write it AB if you didn't want to put the little dot, because that dot will just make your hand cramp if you write it.
Well, I never can see it
I'm
anyway.
teasing. I'm totally teasing. Okay, now, there is a fast way. So if I said, what is the geometric mean of 4 and 5? I'm going to give you the long way and the short way.
Oh.
So pay attention to both. The long way goes like this. 4 over X. This is the next page, by the way, on your notes. It's the next page over. It's 4 over X equals X over 5. Are you with me so far? The geometric mean of 4 and 5. I just put the two numbers in the place of A and B.
Yeah.
And then I say X squared equals 20. Then I take the square root of both sides.
3 square root of 10? X equals.
Question.
No, I got
What?
2 squared 5.
Huh?
Okay,
What?
let's do it together. No,
4.
no, 5 squared 2.
Well,
I
No,
don't know why I put
no. 2. I said it right. 2 squared 5.
Why did I put 90?
Why does it give me this?
Because
Mine gave me a
because
different
because I don't want that is actually
the square root.
the approximate square root.
You want
That
the
I
exact-
want the exact one,
Is
and the
there a way
only
to do that?
no. All right, so what we're going to do is we're going to come over here like we did on the previous slide. I'm going to do 4 times 5, and 4 is 2 and 2. I got a double 2 there. So X will equal 2 square root 5. You with me?
Yeah.
Okay, that's the slow way.
Yeah.
Okay?
There's another way that's quicker.
There's a quick way. Do you know it?
I did mine like this. But I got the same answer.
Yes,
That's
that's
good.
good. And I'm talking about to answer this question, this whole process is the slow way, okay? The fast way,
Yes.
the fast way is like this. Since you know that geometric mean is always going to be X times X, and you know that the two numbers are always going to be on the diagonal,
Just do X equals.
you're just going to go, and you know you're going to take the square root of both sides. you can automatically just say x equals the square root of the two numbers. Automatically. When you, on your Formula Madness, do you have A and B in your Formula Madness?
Z and Y.
Z and Y. So what are you going to write in the square?
X.
X equals square root Z and Y. I'm going to let you know on your quiz, it might not be a Z and a Y, but it'll be two letters. So when you memorize this, I don't want you memorizing that it's the square root of ZY. I want you to memorize it that it's the square root of those two, whatever I put
They're
there.
having a quiz about that.
Yes. Okay. We'll have to explain that in a minute. So your Formula Madness isn't on for the geometric mean is not the square root of AB or the square root of ZY. It's square root of whatever two things I ask you. You with me? So right here, the geometric mean is the square root of those two multiplied together, whatever I give you. So it's really going to be the square root of 20. And then you can do that little piece in the way Heidi did it or I did it or however.
How did you do it, Heidi?
I did 2 times 10, and then
Gotcha. 5 and 2.
Okay?
Yeah.
Okay? So it's still going to be 2 square root 5.
Yeah.
All right? This way means that you have to know a bunch of stuff, and this one means you have to figure it out. But if you know that the geometric mean always has the diagonal being x, then it's going to always turn out to be this. Okay? All right. So let's do I hope it's 15 and 17. Let's just check because my numbers were off last time.
For which lesson?
7-2.
15 and 17? Is that what you just said?
I did, but to make sure that
No.
it is the same thing.
No, 15 was
it's
the...
17 and 19.
It's 17 and 19. Okay,
Yeah.
so let's do 17 and 19. Do we want to do this the long way or the short way? Okay, the short way says
way possible.
the longest way possible.
Obviously.
So it's going to, we just said that geometric mean is,
Sarcastic.
he was.
Yeah, I know.
X equals what?
3 times 27.
81.
Or
Square root
80.
of 81.
Yeah.
Okay, I have 3 times 27, which she says that's 81. Please verify that.
That's what I have as well.
Does 81, is that a perfect square root?
That is 9.
It is 9.
I don't know why I taught that in the calculator. I can't do that.
It's all right. So the geometric mean of
What
3
is
and
a
27.
geometric
We're going to talk about that. We'll just right now you're just going to do the algebra. We'll get what that means later, okay? That way when we get to the point when you have to know what it means, you know how to do the algebra. We're not doing 2 hard things at once, okay? Okay? All right, so the geometric mean of 7 and 28 is x equals
18 is 8, by the way.
square root of 7 and 28.
What?
18 is 8.
Oh, he's giving you the answer, by the way.
Oh.
Yes.
Thank you.
I got the same. Okay, good. That's good to know.
I think this is going to be 7 times
How do you do
7 times 4.
Same.
No.
7 square root 4 is what I got for number 17. Please verify that I did that right.
No, I got 196. So
Okay.
that's going to be
I got
13.
14.
14. Thank you.
What?
196.
What are you guys doing?
So that's going to be x equals
Number
14.
19.
Does 7 go into 28?
7, 14, 21, 28. 7, 14, 21, 28. Yes.
Yeah. So what is 7 times 28?
No. 196.
196.
Oh, because 4 is a perfect square root, of course. What in the world? That's 2 times 2 right there. Yes, you guys are right. I would have had it if I would have just... Yes. Which is going to be 14.
I'm just going to start
All right.
staring at my calculator.
Questions?
I'm confused how you did
Okay. This is what everybody else did, Heidi. They just did this. On their calculator, they took 7 times 28, and they got 196. Stop.
Okay.
What?
And then they checked to see if that was a perfect square root, and it is.
Oh.
It's 14.
Okay.
Okay.
But if it's not, we can't use our calculator.
If it's not a perfect square root, you're going to have to come over here and do your factor tree thing and take everything out.
Yeah.
Can I steal your calculator?
No, I think I'm going to have to encourage his mom to make sure he knows how to do it the other way.
I know how to do it.
Good. Okay.
He just
All right.
takes less time off.
Yeah. Questions?
No.
Can I get a new calculator?
Can I get you?
All right. We're going to do some of one of your homework problems together. This is the last one on 7.2. Your last page of 7.2.
Last page of
All right, we're going to do some of these together. These are ratios of the gravity of different planets.
Oh, hi.
It says the table gives the ratio. Shh. The table gives the ratio of gravity of 4 different planets to the gravity of the Earth. Round the answers to the nearest whole number. I'm going to just come up here to the top before we get anywhere. And it says, I want you to look at this. 4 different planets to the gravity of the Earth. Are you with me so far? That means when we're doing ratios, remember we had A to B? Mm-hmm. That means the first one on the top of the fraction, and then the other one's on the bottom.
Venus to Earth, Mars to Earth, Jupiter to Earth.
Yes.
And Pluto to Earth.
All right?
So is Earth the bottom, since it's consistent 10 and 100?
Yes. Earth, if we had Earth to Earth, we'd have, so that would make
1 to 1.
1 to 1.
Ratio.
So that means Earth's gravity is 1. Okay, you want to make sure you know that, okay? Earth's gravity is 1, and everything else is being compared to Earth's. So Venus is 9/10 of Earth's. Mars is 38 1/100 of Earth. Jupiter's is 236 to 100 to Earth. Pluto's is 7 to 100 compared to Earth.
I'm gonna go with Venus.
Yeah.
You're going to go with Venus?
Yeah.
All right, now how did you decide which planet listed above has the gravity closest to Earth? How did you decide? Is that what you were answering, the one with Venus? How did you decide that was true?
Because it's the smallest one.
Well, this one is 7 to 100 is pretty small. 7 out of 100 is pretty small.
But if it's the closest to 1.
It's the closest to 1,
Right.
yes. 9 out of 10 is closest to each other. These 9 and 10 are closest to each other. 30 and 100 are not close to each other compared to that. And 236 is definitely not close to 100. And 7 is not close to 100.
At all.
Another way to do this is get your calculator out and say 7 out of 10. That's Venus. I'm going to just make a V. Is 0.9.
7 out of 10.
7 out of 10 is 0.9.
9 out of 10.
9 out of 10, my bad, sorry. 9 out of 10 is 0.9. Mars is 38 out of 100, that's 0.38.
0.038. Because it's no longer 10, right?
No.
Oh, yeah,
No.
0.38.
Jupiter is
Is
2.36. And Pluto is 0.07. So the closest one to 1,
Is 9.
this is over 1, this is way under, that's not even half. This one is definitely closest to Earth's. So Venus is the one's closest to Earth. And that gravity has to do with its size. Venus's planet, the planet Venus, is closest. I think Mars isn't. Mars is smaller. Okay. Mm-hmm. All right. Estimate how much a person who weighs 140 pounds on Earth would weigh on Venus, Mars, Jupiter, and Pluto. Let me explain something.
Like a lot of work.
Let me explain something. When you're on Earth, what makes when you step on the scale, Earth's gravity is pulling you down towards that scale and making the dial or whatever's there change. So if you're on a different planet, if you're on a planet that's larger or has more gravity, it will pull you down more and you will weigh more on Jupiter than you will on Earth. Or Venus and all these others, okay? The moon you will weigh less because it's a smaller celestial body, okay? So what we're going to do is we're going to take the person being 140 pounds and since we're going to multiply it by the ratio.
Can we multiply it by the decimal?
9 over 10, yes. And that will, and I don't think it's any harder to just take 140 times 9 divided by 10 on my calculator. You'll just put all that in one foul swoop. And 140 times 9, divide 10.
126.
126 pounds, LB.
What I got.
We're going to do one more, and I'm going to let you do the rest by yourself, now that I showed you how. This is for Venus, by the way. You're going to want to label it so we know which is which. Mars is next. We're going to take 140 and times 38 divided by 100.
53.2.
I heard 53.2. I would very much encourage you on this paper right now, write what I am writing down. So when you get home, you will know what you did so you can do the others.
Every time you write something down, I try to write as much of it
That's
down,
exactly
because
the
if I
best.
don't,
That's
I
the
know I'm
best
gonna
thing to
forget
do,
something.
okay? All right, I'm going to let you finish that up at home. And I'm going to let you finish the last one on that page at home. I got you started.
Wait. Somebody's gonna be decimal.
There, these, I'm going to let you give me a decimal on these, by the way.
Okay.
I'm going to let you give me a decimal, okay?
Wow.
I'm being
That
generous
person would
today.
weigh a lot more on Jupiter.
You are going to weigh more than double what you
Yeah.
weigh on Jupiter. Okay,
Wait.
let's talk about the Formula Madness. If you guys will get out your Formula Madness again, we filled some of them out, but I want to explain what kind of what kind of environment you're going to have for a quiz and what it's going to seem like and look like. Formula Madness. If you'll pull that out for me, I'm going to show you what mine looks like. I have a different one up there than you do. If you guys will turn your page to the Formula Madness, thank you, Brett, for being the model
Oh, wait.
student
Where's
and
the-
getting there as soon as possible.
I don't even know.
These other girls are gallivanting around.
Yeah, right.
All right. I have a different printout than you do, okay? You can print 1A and have both of them. I'm going to tell you why that might be good for you, all right?
What's the difference? They're all the same.
They're the same except in different places.
Look, it's the same as mine.
This is the same as yours?
Oh, no.
No. There's some of them are different.
Several of them
They are the exact, there's 20 on here. 1A has the same 20 that 1B is, except in a different place. I am going to suggest that you print yourself a blank one, put it inside a paper protector, and get out a dry erase marker and practice this. You can first practice it with this in front of you and just copy them. Or you can turn it over and say, how many can I do without looking? I am providing you 1A and 1B. 1A was in week 15s when you printed it. Week 16s has the B, okay? We have filled out as many as we could in class today.
All of them should be filled out.
Some of them, yes. So in other words, you know all the information on this sheet. Next week, I will give you a quiz over these, and this is what the quiz will look like. I will have, this is level 1. You have an A and a B. I'm going to give you a C, and it will look like this, except for they'll be moved around. Okay?
This will be in class.
In class. Uh-huh.
Okay,
Okay,
week,
next week.
will we have a quiz every week?
Every single week of our
What
life.
is it?
Okay, listen. This is what I'm going to do. I'm going to put the timer on for 5 minutes. When I was teaching at the other place that I taught at, I gave them only 1 minute. I'm giving you 5. That means you can do 4 of these a minute. So what I'm suggest you do at home is set a timer and see how fast you can do it, because you're going to be amazed on how much you're going to get this done in way more than you're going to get this done faster than 5 minutes. I promise. You're going to do this. Okay. So you're going to. I'm giving you one of these. It'll be blank. I'll say on your marks, get set, go. I'll say it really calmly so that I don't scare the living stuff out of you. I'll say on your marks, get set, go, and then you will fill them in. All right, and you will have practiced it so much at home that it will be a breeze.
What if we don't entirely, completely, 100% finish it?
That's
on
okay.
time?
Then since their quizzes are worth 20 points. That means each one of these is worth 1. And so if you don't finish that one, it'll just be a 19 out of 20.
What if I was in the process of writing the last one down? Do I
If
still
it's
get it?
not fully done, then you won't get it. You'll be all right.
So
I
wrote,
promise.
like, half of it
You are going to
down.
practice this so much, Amy, that you're going to get this right. Okay? Questions. Any more questions?
What
Now
if
that
we
you
miss
said
a
that,
class?
Say that one more time.
What if you're missing a class?
If you miss a class, maybe your parent will have to do it at home. Okay? All right? Like if you're going to be in Africa on a mission trip and you're not going to be here, then your parent will have to do it. Okay? All right.
Yeah, okay.
All right, here we go.
The end of February.
All right. They will not be in this order. Obviously, they'll be moved around. Okay? All right. This is how Formula Madness will be working for the rest of the semester. Okay? All right.
Do we have a 7-3?
Yes. You better hurry.
Oh,
It's
yeah.
already
These are the things we learned. We did means and extremes, we did reciprocal, we did addition, we did geometric mean. And then it's time to say goodbye.